All right, you need your own copy of the paper, and I need to remember to look here and not at myself there. Okay, question 1. Well, they got 17 out of 30 on average for this paper. Question 1, highest percentage mass of nitrogen atoms. So you've got to put the molar mass underneath. Nitrogen has a molar mass of 14, hydrogen has 1. And so that means that 28 over 32, that's the fraction of nitrogen in that molecule. And then just repeat. I know that that's 14 plus 1 plus 1 plus 1, so that's going to be 14 over 17. Then I've got 14, I've got 28 divided by a big number I don't need to work out, it can't be that one. And this one here, I've got 14, again, over another big number I don't have to work out. So now I have to decide what's bigger, 28 32nds or 14 17ths. I can work that out. Let me just double the top here, 28 over 34. Aha. So now what's bigger, 28 over 32 or 28 over 34? 28 over 32 is bigger, so the answer must be 1A. Ooh, that was a lot of work for the first question. Which statement about mixtures are correct? The components can be elements or compounds. Yep. If you have helium or water or copper, all components must be in the same phase. No, I don't think so. You can have a heterogeneous mixture of like sand and water, I suppose. I'm not sure about that one. The components retain their individual properties. That's true. So 1 and 3 are definitely correct. 1 and 3. Now what about 2? Let's have a think. All components must be in the same phase. No, I don't think that's true. You can have a pepper floating on water. You could mix it in and you could argue that's a mixture. So I'm going to say that's wrong. So 1 and 3, I'm going to say the answer is B. Yes, 2B. Question 3. It's a simple dilution. So you've got C1 V1 equals C2 V2. C1's the concentration at the beginning, V1's the volume at the beginning, C2's the concentration at the end, and V2 is the concentration at the end. So let's just put the numbers in. Concentration at the beginning is 2, and the volume at the beginning is 5. No need to convert to decimeters cubed because I'm going to keep both units in milliliters. What's the concentration at the end? I don't know. And what's the volume at the end? What's made up to 500? 500. So that gives me C2 is 2 times 5 over 500. Cancel that. So that's 2 over 100, which is 0.02. 0.02, which is going to be C. So 3 is C. 3 is C. 4. Which is there. So 0.3 grams of magnesium. So if I've got 0.3 grams of magnesium, let's say this is moles, mass, and molar mass. 0.3, the molar mass of magnesium is going to be 24. Let's just erase this. Magnesium is going to be 24. So the moles is going to be 0.3 over 24 of magnesium, and we're talking about the hydrogen. So 1 is to 0.3 over 24 as 1 is to 0.3 over 24 moles. Okay, now if you want the volume at STP, 1 mole of any gas at STP is 22.7 decimeters cubed. So to work out the volume at STP, I don't have 1 mole. If I had 1 mole, then the answer would be 22.7. But I've got 0.3 over 24 moles multiplied by moles multiplied by 22.7 decimeters cubed for 1 mole. All right then, so I'm going to cancel the moles, and that should be my answer. 0.3 times 22.7. Over 24. That's B. So 4 is B. Nice. 5 is the easiest question. It's quite tedious, so I know the answer is C, so I'm just going to go through that. So you need to know the atomic mass. You'd look that up on the periodic table. Excuse me, the atomic number. You need to know the atomic number. So nitrogen 7, oxygen's 8, carbon is 6. So the neutrons is the difference between those two numbers, which would be 7, 8, and 5. And the electrons, well, you've got to look at the atomic number and then the charge. So 7 electrons and those extra 3 makes 10. 8 electrons and those extra 2 makes 10. And 6 electrons, 6 protons in that atom makes 6. So yeah, the answer is 5C. Each of those contain more electrons than neutrons. Easiest question. Most difficult question. Which electron transition emits radiation with the longest wavelength? So you have to remember that big jump is big energy. Now they want to know about the longest wavelength. So the longest wavelength is going to be low energy. So it's going to be low energy is a long wavelength. So big jump, big energy. Low energy, low jump. So small jump. I'm looking for the smallest jump here. So looking for the smallest jump. And if it's going to emit radiation, it's going to go from a higher energy level to a lower one. So the smallest jump down. So I've got 2 to 1. Okay. I've got 1 to 2. Well, 1 to 2 is wrong. It's going the wrong way. 4 to 1. That's an even bigger jump. I'm looking for the smallest jump. 3 to 2. 3 to 2. So that's the right answer. 6 is D. Of course, you have to remember how the energy levels are spaced. N equals 1, 2, 3, and 4. You have to know that they get closer together the further they go from the nucleus. All right, so that's 6D. Oh, that's my cool sound effect for my phone. That's the Titan landing and Titanfall. Question 7, second easiest. Which element's that? A couple of ways to go about it. You could just... I've done that wrong. That should be 3p2. You could just look at the element that's in the 3p2 block. That's one way. Or you could add up the small numbers, which is the number of electrons. 2, 4, 10, 12, 14. So something with an atomic number of 14. And let's hope it's in the 3p2. So atomic number 14 is here. And it is in the 3p2. This is 3p2. So it's silicon. What's the question? Which group is it? Well, the group is 14, not 4. If your teacher told you 4, that's decades ago. And what period is it? Well, this is period 1, period 2, and that looks like period 3. So group 14, period 3 is D. So 7 is D. 8. Which oxide, when added to water, produces a solution with the highest pH? So high pH is going to be a base, and the strongest bases are group 1 metal hydroxides. So group 1 metal hydroxides are going to have the highest pH. Any of those? No. Bum. Okay, let's do this the hard way then. A, B, C, D. CO2 is an acidic gas in water. It's a natural acid in acid rain, in non-man-made acid rain, just naturally occurring rain. So D's wrong. B's wrong. SO2, so SO3, that's wrong. If you add that to water, then you get sulfuric acid that has a low pH, so that's going to be wrong. We want the highest pH. And so you're left with sodium oxide or magnesium oxide. Well, going back to the fact that group 1 hydroxides have the highest pHs, I bet it's A. That looks the closest to me. So 8A. 8A. Nice. 9. So if it's an electrical insulator, then it can't be ionic. So it can't be ionic, whatever we're talking about, because if you melt an ionic compound, you have freely moving ions and they conduct electricity. So it can't be ionic. Definitely can't be metallic bonding, because that conducts electricity both as a solid and a liquid. Freely moving delocalized electrons allow that to happen. So we're just left with covalent. Now there's two sorts of covalent compounds. You've got something simple like liquid water, or you've got something huge like a big lump of diamond. So giant molecules or simple molecules. Well, if it's got a high melting point, it has to be a giant molecule. So I'm looking for something like diamond, which is 9A, network covalent or giant macromolecule. 9A. Lovely. 10. Which atoms form the most polar bond? The IB have cocked this question up in the past. The trick is you need to look at their positions on the periodic table. The closer they are together, the more similar their electronegativity, and the less polar the bond. The further apart they are, the more different their electronegativity, their electron love, and the more polar the bond is. Of course, if they're very far apart, they're going to have such a big difference in electronegativity. It's going to be an anionic bond as one electron transfers to the other. So we've got carbon and fluorine, carbon and chlorine, silicon and fluorine, and silicon and chlorine. Okay, so we want the two that are the furthest apart. Oof, that's not a very fair question. The two that are furthest apart are carbon and chlorine, or silicon and fluorine. So how are you supposed to know which is which? I think we'll go with silicon and fluorine, since fluorine has the highest electronegativity. That's 4, even though carbon and chlorine is tempting. So silicon and fluorine C, 10 is C. I don't think that's very fair. How have they cocked it up in the past? They've chosen hydrogen, which is way over there, and the distance rule doesn't really work because hydrogen's in a strange place. A bit like we all are with the pandemic. So 10 is C. 11, the sulfite ion. Well, let's draw it out. Sulfur is in group 16, 6 valence electrons. Oxygen is in group 16 as well, 6 valence electrons. And we've got 2 extra electrons. Divide by 2, because I want to know how many electron pairs. 6 and 6 is 12, 24, 25, 26. That's 13 electrons. All right, then put the first one in the center, sulfur. Spread the others evenly around. And now I have to distribute 13 electrons, making sure that both oxygen and sulfur have 8 electrons, 4 electron pairs around them. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 12, 13. Oh yeah, that's it. That's weird. So I've got 12 electron pairs there, and then the 13th one goes on there. If you were writing it out for points, you'd have to put square brackets and a -1. Okay, so number of electron domains around the sulfur. I've got 1, 2, 3, 4 electron domains, so that leaves me with C or D. Electron domain geometry. Well, the electron domain geometry is a tetrahedral. There's 4 of them, if you're just looking at the electron domain geometry. So tetrahedral, so that's going to be D. Let's double check. molecular geometry, trigonal pyramidal. Yep, and that angle there. So 11 is D. 11D. Let me mute this. Question 12. People struggle with this, or maybe they just struggle learning it from me. I'm not sure. Which correctly states the strongest intermolecular force? So intermolecular force is between the molecules. Not within the molecule, it's between them. In between. All right then. So I've drawn the molecules out here. Sometimes it's easier than you think. The intermolecular force here is going to be H bonding. Now don't think that this is a hydrogen bond. It isn't. It's a covalent bond. But it allows hydrogen bonding between one molecule and the next molecule. So if I know that that's hydrogen bonds, is that it? Okay, that narrows it down to A or B. Now, I just have to work out which of these has a dipole. Well, it seems clear that this has a dipole here. Chlorine is very electronegative. It loves electrons in their bonds more than the carbon. So it's going to drag the electrons up to the top of the molecule. It's going to give it a dipole. So chloromethane has a dipole, so 12 is B. Okay, before we do question 13, here's a graph of COVID. Unfortunately, I'm living in the country that's going up and up and up, the Czech Republic. That's why I'm staying indoors. Question 13. Which expression gives the mass of ethanol? Oof. Okay, so if I have 1 mole of ethanol, that's going to be 46 grams, and that's going to produce minus 1367 kilojoules per mole. All right, that's data from the question. If I want 683, okay, I want 683, then what's the question? How much mass do I need? Oh, so this is the unknown here. 46 grams gives this much, so I don't know how many grams gives that much. All right. So isn't it just cross multiplication now? I've got 46 times minus 683 divided by minus 1367 equals x, which is my unknown. 46 times minus 46 times. Is that C? 13C? It is. Nice. 14 looks tricky. I'm not even going to read the question. So the arrows going this way equals the value of the arrows going that way. So clockwise arrows equal counterclockwise arrows. So I've got delta H plus delta H2 equals delta H1. So if I want delta H, that's going to be delta H1 minus delta H2. Delta H1 minus A, 14A, bang. 15, hydrogen peroxide, oxygen and ozone. I used to have beautiful long blonde hair. Hard to believe that. Maybe I'll post a picture one day. So just drawing out the Lewis structures. I've got hydrogen peroxide, I've got oxygen, and I've got ozone. So this is a single bond. This is a double bond. Well, it seems like we have a choice. Oh, I forgot those lone pairs. It seems like we have a choice here between a single or a double. Well, actually, it's a resonance molecule. So the single and the double swap places so quickly, they're effectively only a 1.5 bond. So this is a 1.5 bond. All right. To bond enthalpy, so from the lowest to the highest. So this is the lowest, and this is the highest. So low H2O2 and the highest is O2. It's going to be B, 15B. 16, the third easiest. Copper catalyzes the reaction between zinc and dilute sulfuric acid. What does a catalyst do? Decreases the activation energy. 16A. Yet catalyst decreases the activation energy, provides an alternate pathway, and remains unchanged at the end. 17. Alright, so everything's the same except you're using twice as concentrated hydrogen peroxide. If you're using twice as concentrated hydrogen peroxide, you're going to make twice as much oxygen. So which of these graphs seems to show twice as much gas being produced? Well, it seems A to me. That seems too easy. 17A, yeah. Twice as many moles of hydrogen peroxide because you've got twice the concentration. Makes twice as much gas. 18. Equilibrium, what's going to shift it to the right? What's going to shift it to the right? If you increase the temperature, it favours the endothermic side, and this is indeed the endothermic side. So increasing the temperature, that's true. It will shift to the right to cool itself down. Decreasing the pressure, if you decrease the pressure, it favours the side with the most gas particles. On this side there's one gas particle, on this side there's two. So that's true. Decreasing the pressure is going to shift it to the right to favour the most gas particles. And 3, adding a catalyst, well, that increases the rate of reaction of both the forward and reverse reaction equally. But it doesn't change, it doesn't favour the right. So it's 1 and 2, 1 and 2 is A, 18's A. 19's trivial, the difference between a conjugate acid and base is H+. So identify which of those pairs are different by H+, and that is D, 19D, different by H+. 20. Another pH one? It's a bit saucy. Alright, highest pH. So that seems very familiar. The highest pH, so we're looking for a group 1 metal hydroxide. Those had the highest pH. Is there a group 1 metal hydroxide? No. Okay, so we've got A, B, C, D. So B is an acid, has a low pH. That's wrong. C, sodium chloride. That's wrong. It's neutral. So you're left with ammonia or ammonium chloride. This seems like a higher level topic to me, although the IB claims in their examiner's report this was a fair question. I don't think it is. Let's just go with ammonia. I think ammonia is the answer, even at SL. 20D. 20D. Yeah, don't like that. Don't like this distractor. 21. The way you work these out is the most reactive ends up as an ion. So whatever's an ion at the end of the equation is the most reactive. So looking at the first one, I've got zinc plus tin 2 plus goes to zinc 2 plus tin. Zinc ends up as an ion at the end of the reaction, so zinc is more reactive than tin. Zinc beats tin. By the same logic, zinc also beats copper. So zinc beats copper because it ends up as an ion at the end of the reaction. The reaction doesn't happen, so it stays an ion. Tin beats copper. So tin beats copper. And copper beats silver. Copper beats silver. So by doing a little in your head, you've got zinc, then tin, then copper, then silver. Zinc, tin, copper, silver, D, 21D. Yep, most reactive ends up as an ion. 22, half equations. Ooh. How much bother are they going to want me to do here? Okay, so basically just split them into two. I've got I2 turns to 2I minus, and then I've got S2O2 2 minus turns to S4O6 2 minus. Right. So I don't want to do both of those. I want to work out which one I need. So I need the oxidation. Oxidation is loss of electrons. Well, let's see if it's this one. Oxidation state of elements is 0. That's -1. So if it goes from 0 to -1, that's reduction. That's not the equation I need. That's the reduction equation. I need the bottom equation. Okay, it's going to take more than a minute and a half. Oxygen in the compound's -2. Sulfur must be +2 +2. Am I overthinking this? Yes, I don't think I need to prove it. I need to just balance it. So let's try to balance it. Oh, that's just trick upon trick here. This is a beautiful question. It looks like there's 2 electrons on each side, so it's all balanced and ready to go. But there's actually 4 electrons here because there's 2 lots of that. So I have to balance that out. So the charge on both sides is now equal. Which one's that? That's C, 22C. Oh, that was a beautiful question. So many little tricks and traps. 22C. 23. Oh, I hate these ones. If I'm going to get one wrong today, it's going to be this one. Voltaic cell. So the voltaic cell is the one with the salt bridge and the voltmeter. Don't get it confused with electrolysis. It's this one. I can do these questions, but I have to work them out from first principles. Maybe. A spontaneous redox chemical reactions produces electrical energy. Well, that's true. Yeah, it's actually a battery or a cell you've made. One's right. Is that enough? Is that enough? All right. My choices of A, B, C, and D. C's gone. Okay. Oxidation occurs at the cathode. So I remember red cat. Reduction happens at the cathode. They say oxidation happens at the cathode. No, red cat. Literally a red cat. So that's wrong. So 2 is wrong. Is that enough? 1's right and 2's wrong. Yeah, it's B, 23B. That wasn't so painful. I actually 3D print red cats, give them out as prizes when I used to go to school. Okay, increasing boiling points. Let's have a look at these molecules. I've got butane. I've got, that looks like ethanoic acid. Ethanoic acid. I've got propanol. And I've got propanol. Increasing boiling point. Well, let's start with the lowest one first. The lowest one's going to be butane. It's just got London dispersion forces, the weakest of all the intermolecular forces. So butane has the lowest boiling point. Is that enough? That just narrows it down to A, B, and D. C's wrong. Okay. What has the highest boiling point? Well, the highest boiling point is going to have the intermolecular force of hydrogen bonds. That's the strongest intermolecular force. So that leaves me with propanol or ethanoic acid. Now, ethanoic acid, acids have higher boiling points than alcohols. This extra oxygen here provides a little bit of cheeky extra dipole. So ethanoic acid has the highest boiling point. Is that enough? Yes, it is. B, 24B. Let's check. 24B. Yeah, didn't have to do all of them. Just the most and the least. 25. What are the functional groups in the aspirin molecule? So they say ether. This is ether. Do I see an ether? Yeah. There's an ether. So, yep. A carboxyl, like in a carboxylic acid. That is this. Do I see a carboxylic acid? Yep, there it is, carboxylic acid. So 1 and 2 is correct. I'll have to check 3. And 3 is an ester group. Ester is this. Do I see an ester? I think I could have made a mistake. This here is an ester, not an ether. This here is an ester, not an ether. So I take it back. I don't think I can see an ether anywhere. So 2 and 3. 2 and 3, C. 25C. Yes. Oh man, I'm going to get all these right. Fantastic. 26. Name this for the IUPAC rules. So longest chain, 1, 2, 3, 4. So it's going to be bute something. I see a carboxylic acid, so it's going to be butanoic acid. And now I just have to decide if it's 1, 2, 3 methyl, or if it's 1, 2 methyl. Well, I'm going to start from the end. Excuse me. You need to start counting to get the lowest numbers. Well, that's normally true, but if there's a functional group, a big functional group stuck at the end, you probably want to start counting from there as well. There are 72 rules, of which we don't go into all of them. But however you count, you're going to get a 2 here, aren't you? If you count from the functional group, or if you count from the smallest number, 2-methyl butanoic acid. That's C. 27, 26C. Nice. 27, there's a very unexplored part of the syllabus, tertiary nitrogen. Well, if I tell you this is a secondary nitrogen, because there's 2 alkyl groups attached. If I tell you this is a tertiary nitrogen, because there's 3 alkyl groups attached. I tell you this is a primary nitrogen, because it's got, well, not an alkyl group, but it's got 1 carbon-based group attached. And this is a quaternary, because it's got 4 alkyl groups attached. So the question wants to know what's tertiary. It's this one. A nitrogen with 3 carbony groups attached. So what one's that? That's going to be... That's going to be C, 27C. Nice. 28, H1NMR. Measures the hydrogen environments and the ratio of hydrogens in those hydrogen environments. And HL does a little bit of splitting and stuff. It also, if you look at the chart, you can tell what that hydrogen comes from. Is it from an alcohol or is it from a carboxylic acid? Overthinking it here, what can it tell you? Can it tell you the bonds present? Maybe. You can look it up in the table and see that, maybe. The molecular formula, that's a mass spectrometer where you snip the molecule into pieces. Molecular mass, that's the mass spectrometer where you snip it into pieces. Number of hydrogen environments, D. So 28D is the best answer. 28D, yes. Although A is tempting. I think A, for bonds present, they probably meant infrared. 29, density. So this is the symbol for density, rho. Density is mass over volume. So I've got 34.79 divided by 12.5. So that's going to be just under 3. So my answer is going to be C or D. It's just under 3. Then you have to think about the sig fig rules. This has 4 sig figs. This has 3 sig figs. So your answer needs to have 3 sig figs. Goes with the lowest in the question. So that's 29D. Yep. And 30. Index of hydrogen deficiency for hexatriene. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. 6. And it's 1, 3, 5. So the index of hydrogen deficiency, every carbon-carbon double bond counts as 1. Every carbon-carbon triple bond counts as 2. And every ring, be it a hexagon or a triangle or whatever, every ring counts as 1. So I count 3 carbon-carbons, 3 of them, so that's going to be B. 30B. Got them all right. And I didn't cheat. Well, I used to do this for a job. Good night.